If you go to the Google Classroom, you can find this PowerPoint and you can follow along if you want to. So I think you guys are pretty good with understanding what formulas are. For example, calcium chloride is sorry, I can't write this more clearly, Cl2, because Ca is from the left, it gets a +2 charge, Cl is from the right, it gets a -1 charge. Crisscross applesauce, you have a 1 here and a 2 there. We don't write ones, it's CaCl2. Ammonium sulfate. Ammonium is NH4 with a +1, sulfate is SO4 with -2, so it's NH4 so put that in parentheses, NH4 2, and then SO4, because NH4 is a +1, SO4 is a -2, you need 2 of these. So while you use molecular compounds too, dicarbon means 2 carbons, and tetrachloride is C2Cl4. And then iron 3, iron's in the middle of the periodic table. So you don't know what the charge is going to be for it. Calcium, we know it's going to be a +2 because you can see it in the periodic table. Ammonium's going to get a +1 because I know that from my flashcards. Iron 3 means Fe has a +3 charge. Fe, so if that has a +3, and carbonate is CO3. Let me think. Flashcards -2. So a +3 and a -2. And so it's Fe2, CO3, 3. That's really ugly. Sorry. So we're going to look at skeleton and balanced reactions, and we're going to focus on states of matter because we need that especially for double replacement reactions. And then we'll practice. So the first thing is, this is a skeleton reaction because you don't have anything here or here or here. It's a skeleton reaction, but when it's balanced, you put in coefficients like 4 and 3 and 2. Those are coefficients. So you have the same number of Fe's on the left as on the right, 4. You have the same number of O's on the left as on the right. That would be 6 on either side. Here's some examples for you. You can look at those. Now there are 5 different kinds of reactions that you'll need to know. There are combination reactions, also known as composition or synthesis, decomposition, which are the opposite of combination reactions, combustion, that's like burning, single replacement, and double replacement reactions. So here's what a combination or a synthesis reaction looks like. You have one thing, 2 things on the left, and they combine together to make one thing on the right. A couple small things, 2 or 3 or 4 small things make one big thing. Decomposition, one big thing on the left is broken down into 2 or 3 or sometimes 4 or 5 different compounds. It's broken down into decomposition. Combustion, always have some sort of carbon source. That's a fuel. It could be wood, it could be octane and gasoline, it could be kerosene, gasoline, something that burns. And then you always need oxygen to make a fire go, and you always get out CO2 and H2O. That's what comes out the tailpipe. Then single replacement reactions. Usually single replacement reactions are going to be 2 metals, things from the left side of the stair step, that are going to be fighting for some sort of anion. In this case, it's copper fighting with silver. So silver right now is very happy. It's bonded. Who's going to end up winning, silver or copper? So you look at this series, which is on the back of your periodic table, and whichever one is more like Larry Lithium wins. So here we have copper fighting with silver. Copper, copper, there you are. There's copper. I'm circling it. There's silver. Wait, even though copper is not very high up on the activity chart, it's still higher than silver, so copper is going to end up with a buddy. And so when the reaction's done, and I can see that because here's the arrow, when the reaction's done, copper is going to end up with the buddy. In this case, it's copper to chloride. Copper gets a +2 charge. It started with a 0. Now it has a +2 charge. Now it could get a +3 or maybe a +1 or +4 even. That you have to kind of figure out from reading what is likely to happen. But anyway, copper ends up with a buddy. And silver is all by itself, just pure silver laying there in the bottom as a solid, laying there in the bottom of the test tube. Double replacement reactions. You have a cation and an anion and a cation and an anion. This is not exactly the right way to say this, but sometimes people, refer to it as like a girl and a boy and a girl and a boy. And then they switch out and they're dancing, and then they switch partners. So then this girl goes with this boy, and then a little bit later this girl and this boy dances together. You can tell if they're going to go because you'll end up with more solids and or liquids and or gases on this side of the reaction. It will proceed if you get more solids and or liquids and or gases over here. And you can find whether or not things will be solids, liquids, gases, or aqueous on the back of your periodic table. Up here, you can tell solids, liquids, gases. So here's a combination reaction, also known as a synthesis reaction. Two things make one thing. They combine together. Two things here. This is going to make NaCl on the right. NaCl. Now you don't necessarily take the 2 across. Do not just automatically put a 2 there. As a matter of fact, it's wrong. You know that Na gets a +1, Cl gets a -1, so you do it in 2 steps. Number 1, you figure out what is the correct formula. Na plus, Cl minus. All right, this makes sense. Now, balance it. 1 Na on the left, 1 Na on the right, 2 Cl's on the left. We need 2 on the right, so I can only put a coefficient right there. Dang it, I just wrecked the NAs, 2 NAs. I have to come back here and fix this. But balancing is usually something that you guys are pretty good at. And you did the online balancing thing, so I hope you did a good job at that. These two combine together to make, guess what? H2O. So you have to really think it through. What would oxygen and hydrogen combine to make? Okay, decomposition reaction, exactly the opposite. So one big thing, calcium carbonate, is broken down into 2 smaller things. And then you have to balance it. One big thing, ammonium. This is ammonium. This is nitrate. Now, don't you see why I had you memorize your flashcards? That's broken down into a couple of small things. How about this one? Let's figure it out. Ag2O. What could that be broken down into? Solid silver, like on a silver ring, and oxygen, but oxygen by itself, that's not right. It's O2 if it's all by itself. Now balance it by putting a coefficient here, and or here, and or there. Okay, combustion reactions. Always have some sort of carbon containing something. You always need oxygen. You always make CO2, and you always make water. So down here, there's your fuel, there's the oxygen. Here you write CO2, and you write H2O here. Although you can write H2O and then CO2. There's no rule about it. What about this last one? Well, there's the fuel. You need oxygen here. You need CO2 and H2O there. Balance it. Now here come the tricky ones, single replacement and double replacement. So single replacement reactions. Take your yellow periodic table, turn to the back side. I think I gave this to you in Google Classroom. Look right here. It says activity series. Larry Lithium. He's the most amazing. Here, look on the slide. Larry Lithium right up here. Larry, oh, isn't he amazing? He always ends up with the buddy. So he started off by himself, and this guy here, Gary Gold. All right, poor Gary. He was dancing, he was all happy, but then that darn old Larry Lithium ends up with a buddy, and poor Gary Gold is out there on his own. Oh, so sad. So this is the one that we looked at before, copper versus silver. Who's going to win? Let me look at the back of my periodic table. Copper wins. So this reaction occurs. Here, lithium all by itself. Well, that's Larry Lithium right here. That's this guy, Larry. Hey, Larry. Larry Lithium walks in, and there's, let's see, iron. Ike Iron is dancing with a girl's name that starts with H. Haroldine. Haroldine, is that a word? Is that a name? Haroldine hydroxide. So they're dancing, and then Larry says, "Get out of here, Ike Iron." And poor Ike Iron is all by himself. Oh, how do you know this? You look it up on the back of your periodic table. So sometimes people say Hills, high ion, low solid. That's how you remember this. All right. But I always remember Larry Lithium. He always ends up with a buddy. And poor Gary Gold never has a friend. But that's why gold is so valuable, because gold doesn't react. Gold is always by itself. So if you're trying to figure out will these reactions occur, this reaction here, all right, well, you have tin all by itself. Going to fight with Na. Who's going to win? Well, let's see. Here's Na right there. And where's tin? Oh, no. Tin's not going to win. Tin's all by itself. And it's going to end up all by itself, too. This reaction will not occur. You can mix those together. Nothing happens. But if you put sodium in a solution of tin nitrate, tin 1 nitrate, sodium is pretty much like Larry Lithium, and so sodium will take the place of tin, and tin's out on its ear all by itself, standing there lonely, and sodium and nitrate are together. And you can look at all of these and figure out what happens. Double replacement reactions, they're pretty tough too. So double replacement. You have a cation, anion, cation, anion, and they're dancing. So you can think of it as a boy and a girl and a boy and a girl. Cation, anion, cation, anion. Plus, minus, plus, minus. Sometimes they'll switch partners so that this guy is going to be with this girl and then this guy with this girl. Now you always write the cations, the plus charged ones first. This reaction will occur. Yes, it will occur. In other words, you're going to end up with these products if you make more solids. I'm going to circle that down here. Solids and or liquids and or gases. If there's more solids and or liquids and or gases on the right side, then yeah, that reaction occurs. But if you start off with more solids and or liquids and or gases on the left side, then you can mix those two together and nothing happens. So here we have HCl and NaOH. Look it up on the back of your periodic table. HCl is aqueous, AQ. Sodium hydroxide is aqueous. That means in water they dissolve and you can see through them. It might look like Mountain Dew, where you can still see through it. It might have a color. It might be red or green or blue, but you can see through it. That means it's aqueous. Now HOH is not an aqueous solution. It's a liquid, L. NaCl, look it up on the back of your periodic table and it says aqueous. Okay, the question that you have to ask is, does this reaction end up with, afterwards, is there more solid and or liquid and or gases? Yes. There's a liquid on the right, but there's no solids and or liquids and or gases on the left. This reaction will occur. You mix these two together, you mix HCl with the NaOH, the reaction will occur, something cool happens, and you know that by using your solubility chart on the back of your periodic table. Here you've got an aqueous, the second reaction. Aqueous, aqueous, solid, aqueous. Are there more solids and or liquids and or gases over here? Yes, reaction will occur. But this last one, you got a solid and a solid make, there's the makes, aqueous and aqueous. Question, are there more solids and or liquids and or gases over here? No, there are not. That means if you mix these two things together, the calcium nitrate, you mix it with iron chloride, iron 2 chloride, you mix those together, nothing happens. It just sits there and nothing occurs. This reaction will not occur. You would write down NR, NR, no reaction. Here's that chart on the back of your periodic table that you use for double replacement reactions. Either things are aqueous, which is also known as soluble, or things are solid, which is also known as insoluble. And so you just look at this here. All fluorides are aqueous. There's a few exceptions. And so you just look them up here. If they're not aqueous, they're solid, 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 solid. All right, that's how that works. And then the next thing that we'll be working on is stoichiometry, and that's pretty cool stuff. All right, thanks everybody. Bye.